Okay, so there's some different ways that you could sort of tackle this question or look at it. It's one of these ones that's different from the other questions that we've seen, so we need to think about what information we have, what we're trying to find. This angle is ultimately what we're trying to find. Find the angle, the second wire, second cable, so this is the second cable. This is the first cable, makes an 80-degree angle, right? There's the 80-degree angle. So find the angle the second cable makes with the ground. So that's theta, as I've labeled in this diagram. Then we also have to think, what can I find? Well, this is 80, this is 90, so I can find this one. It's going to have to be 10 degrees so that those three angles add up to 180. This angle here will have to be 100 degrees, so that angle and this angle, I don't want those to disappear. I'll put those back 100, so that angle adds up to 180 with this angle. So here's my 10 degrees. That's all I can find easily. The rest of it I'm going to have to do some work for. So now what I'm going to think is, one more thing that's important to know for sure is that it is 3 times as far from the pole as the first cable. So the first cable is 7 meters from the pole, so this one is 21. And if I just label those in the diagram like that's showing my work well enough for this question. I don't have to necessarily let that be x, and then x is 3 times 7 or something. I think that's overdoing it for this. So if I label it on the diagram, then that's good. So I've got that 21 meters. Now what I'm going to do is I'm going to think, what would help me to find theta? This demonstrates a very good understanding. This is a great question for you to reflect on your understanding of trigonometry in general. So I've got this big triangle. Okay, this is, so the second cable would be going down somewhere like that. Okay, but I'm not going to draw it. I'm going to leave it out. I guess maybe it is going to stay there. Maybe I can get rid of it. I'm going to erase the whole triangle if I get rid of it. That's okay. All right, so put the triangle back. Okay, like that. Okay. And so this is my theta. Same theta as in the other diagram, right? But the middle cable is missing. What information do I need? Oh, and I know this. What information do I need in order to find theta? So it's a right triangle, and for right triangles I use SOHCAHTOA. And SOHCAHTOA, if you have one angle and one side length, you can find another side length. If you have two side lengths, you can find an angle. Well, I'm looking for an angle, and so to use SOHCAHTOA, I need to know two side lengths. I've got one, okay, and it's adjacent. So I need to either figure out the opposite side length or the hypotenuse. And if I go back to this triangle, this is the opposite side length, this is the hypotenuse. Which one of those, or maybe both, which one of those can I figure out? I actually, in this case, don't think I can figure out the hypotenuse because it's not in the smaller triangle, it's only in the bigger one. And I don't know any other information about the bigger triangle. If I could find that angle, then I'd be done. I wouldn't have to do any of this. And theta is the angle I'm looking for. So I don't have any of that information. So, but if I ignore the bigger triangle and I just look in this smaller triangle with the 10 degree, well, I've got an angle and a side length. And as I said before, with an angle and a side length, again, it's a right triangle. I can find another side length. So if I find this side length in the small triangle, it's the same as opposite in the big triangle, and then I can use that to find the answer. So that in general is how you would do it. If you understand that, I would suggest you pause this video and go try to do that on your own. But I'll finish the solution, and then you can come and compare yours to mine. Okay, so I'm going to call this, I'll just call this x. Okay, so I'm going to find x first, which is going to be, the side length in the small triangle, but it'll also be x in this triangle, my big one. And so then looking at the small triangle across from the right angle, this would be my hypotenuse. Across from the angle, I'm going to use this angle that I'm given, the 80. So across from that is my opposite, and this is my adjacent. So I know the adjacent, and I'm looking for opposite. That's tan. So I'm going to start with that. Tan. I'll zoom out so we can see the whole thing. Tan theta is opposite over adjacent. And I said I was going to use the angle of 80. I'm not going to switch that to 10. I'm just going to stick with 80. That's how I label the triangle. So tan of 80 is opposite, which is x, over adjacent, which is 7. Rearrange. And on my calculator, 7, I'm in radians. Make sure you're in the right mode, degree mode. 7 tan 80 equals, so this is a side length, but it's approximately 39.69897. I'm just going to write an extra one because otherwise I'd have to erase to round properly. So remember, keep 4 decimal places at least. 5 is better. The more the better. And I'm just going to keep it on my calculator as we've done in class so that I can get an exact answer. Okay, so now I know that this angle is approximately 39.7 meters. Okay, this side length, sorry. So I'm going to do tan again. I've got that, and I've got this adjacent, so I can do tan again. So tan theta, and that's going to be the actual theta this time, is opposite over adjacent. So I'll leave it as theta, that's my unknown, is opposite, which is that 39.7. Again, I've got all those digits still on my calculator, over 21. And this is the kind you're looking for an angle. So it's shift, tan, bracket. And here I'm going to do that now. Shift, tan, bracket. My answer, so I hit the answer key on my calculator to get the 39.7, 39.69897, so on, divided by 21, hit equals. I got 62 point. You don't need to write all this down. You're done, so you could stop here, but and it says rounded to the nearest degree, so I'd stop at 62. But just in case you want to compare your answer to mine and make sure you did it exactly right, this is what showed up on my calculator, okay, which is approximately 62 degrees. Therefore, second cable makes an angle of approximately 62 degrees with the ground. Okay, and so that's how you would solve that question. Good question. Thinking about the information you're given, how you use that to figure out what you need to know.